Let's see how to carry out the design and calculation of photovoltaic installations using the Open BIM workflow. The first step to creating a BIM project is to create a directory to store and consolidate the contents. This project is based on an architectural model in IFC format. The project building can be modelled with different software, as long as they work with the IFC standard. In this case, the architecture of the building will be modelled using the free CYPELEC architecture application. Once the modelling is completed, we will be able to export the IFC to the BIM Service Center platform, where it will be included in the BIM project. To model and calculate the photovoltaic installation, we will use the CYPELEC PV system software, which is included in the CYPELEC Suite collection of applications. We start by assigning the project to the installation to which it belongs, which may have been previously created by us, or we may have been invited with a collaboration request. Through this process, the program reads the information already included in the project and imports only the required information. The application allows users to create and edit the modules and other elements of the equipment that will make up the installation from the Elements library, so that new photovoltaic panels can be created. These new panels will be designed by entering the respective electrical features of each model. The inverters, accumulators and regulators will also be created in the same way. Additionally, the program contains cable families from different manufacturers such as Prysmian and Top Cable, which can be entered in the project. On the other hand, in the General Settings tab, users can configure general data such as the maximum admissible voltage drop, orientation of the project with respect to the north, minimum autonomy of the installation, and minimum power of the inverter with respect to the installed power of the photovoltaic installation. It also allows users to select sections of cables and the diameters of the electrical protection elements available for the installation. Furthermore, the range of power of the installation can be determined either by entering them manually or by using the loaded standard specifications. The application also makes it possible to configure the design conditions for the calculation. In this window, we select if the installation will be isolated or connected to the network. It also allows the building to be located by automatically reading the average monthly value of the daily irradiance. The performance of the installation will be calculated according to the losses entered, and it even gives the option of choosing the period for which the design is carried out. Before modelling and calculating the installation, the program allows an energy pre-design to be carried out. For an installation connected to the network, users can select the number of solar panels, the type of module, and the inverters. It is even possible to enter the production and consumption values month by month. These production values can be entered manually using the clipboard or by importing a file in CSV format, extracted from the European Commission's Photovoltaic Geographical Information System. To download the file of daily data, simply select the location of the project, the month, and fill in the necessary data in the respective boxes. Next, the consumption will be entered by pasting from the clipboard. After entering this data, the months will be defined energetically as shown in the graph. In order to add up the costs each month, the program allows the cost to be entered for both the installation elements and the energy. In this way, the pre-design will be completely defined, allowing the monthly energetic breakdown to be viewed. This breakdown changes as the number of panels is modified until the optimum level desired by the designer is reached. For an isolated installation, the demanded energy must be entered either manually or calculated according to the consumption forecast. The consumption can also be entered manually or imported from the library included in the software. Then, users must select the photovoltaic modules and the different elements that will make up the installation, as well as the autonomy of the installation and the maximum allowable loss. Once the data has been entered, the pre-design will provide us with a report of the quantities and the elements required. We will continue with modelling the installation. First, we will select the type of solar panel, in addition to the type of installation, the orientation, and the slope. When selecting the horizontal plane installation type and inputting an inclination, the application allows it to be easily inserted into the 3D model. If the overlay option is selected, clicking on Update Results after we have placed the photovoltaic module enables the program to detect the roof plane and align the module with the roof slope. Like the panels, the remaining elements will be placed in the 3D model. Once positioned, the installation will be connected by conductors, with the option of choosing from the manufacturer cables previously loaded in the job. In the cable section, the protections included also have to be selected, as well as their method of installation. This can be done by clicking on Pipework. Once all the elements have been connected up to their network connection point, the installation will be calculated and the program will display the error warnings on the conductors that do not meet the requirements. Clicking on each conductor will show the checks that have been performed on it. With this information, conductors that do not comply or those that exceed the compliances can be modified according to the designer's criteria. Furthermore, the program allows a single line diagram of the installation to be automatically created and placed on the most suitable type of plan. Finally, the application provides the possibility of generating a bill of quantities of the installation. This would require defining the prices of the materials and assigning them to a category. This information is given by default for the materials that are already loaded in the program. For those created by the user, the category will have to be defined and the price assigned from a cost database included or imported to the program. Once the previous step has been carried out, the reading of the installation will be updated, first generating the bill of quantities with its respective items. Upon finalising the design and calculation of the installation, the job can be exported to add the information together with the rest of the project's disciplines stored on the BIM Service Centre platform.